Welcome to RK Tutorials. Solutions to Engineering Mechanics Textbook, 5th edition by S. Timoshenko, D.H. Young, J.V. Rao, Sukumar Patti. In this tutorial, we will solve the problem set 2.2, problem number 2.19. Determine the magnitude and direction of the resultant of the four forces shown in the figure. In this figure, four forces are given. One force is 890 newtons acting downwards. Another force 445 newtons acting towards left side. Another force of 445 newtons inclined. And the last one is 1335 newtons force also acting inclined. Our interest is to find the magnitude and direction of the resultant of these four forces. For this, we will use the concept of resolution of a force. The resolution of a force concept I already prepared video and uploaded. Please watch that video. Now let us go to the solution of this problem. Let us transfer all these forces onto an XY plane to easily understand and analyze this problem. So first I am transferring, let us say this is my x-axis and this is my y-axis. I am transferring all the forces onto this XY axis. First, that 890 newtons acting downwards, I am transferring to that my XY plane. Next, that 445 newtons. Next one, the inclined 445 newtons and that 1335 newtons. Now, 890 newtons force vertical I know. This 445 newtons horizontal I know. But the remaining two forces, that 445 newtons and 1335 newtons, these angles are not known. The first step in this problem is to identify the angles made by 445 newtons and 1335 newtons with the x-axis. Let this angle is alpha and that angle is here alpha. Now how to find that alpha? Just consider a small graph sheet that he has given in the problem itself. Let us consider this is 1 unit. And if you consider this, the force is intersect at this point. So if you construct a right angle triangle here up to this point like this. So this maybe I can consider as 1 unit, let us say x. Obviously the second one also becomes x and this height is 1 unit. So I can consider as x. Then I can calculate tan alpha, that is equal to x divided by 2x. So alpha becomes 26.56 degrees. So this I can consider as 26.56 degrees. Similarly, I can calculate the beta value. Let beta is the angle made by the 1335 newtons force with the x-axis. Let this angle is beta. Now how to find? Just consider the same concept. The force is intersect here. So I can draw a right angle triangle like this. Let this distance is x and let this distance is x. Now this tan beta I can say x by x or beta is equal to 45 degrees. Or you can take another intersect. This is another intersect point. If you consider the triangle here, this also you will get x and x and x and x. So you will get tan beta is equal to 2x by 2x or beta is equal to 45. So you will get beta is equal to 45 degrees. Once you know the angles made by these forces with either x-axis or with y-axis, and resolve these forces along x and y-axis. This 890 newtons is along y-axis, you need not to resolve. This 445 newtons along x-axis, you need not to resolve, but this 445 newtons is inclined, which makes an angle of 26.56 degrees that we want to resolve. If you resolve this force, I will get x component is like this, y component of force is like this. Then what is the magnitude of the x component? This 445 newtons makes 26.56 degrees with the x-axis. Hence, x component is the sine component, or the horizontal component of 445 newtons is equal to 445 into cos 26.56, which gives 398.03 newtons. And what about the vertical component? Obviously, this becomes a sine component. The vertical component of 445 is equal to 445 into sine 26.56, which gives the value 198.97 newtons. Similarly, 1335 newtons force I want to resolve along x and y axis. If you resolve this along x axis, that force direction will be like this, and the y component force is along like this. What are those magnitudes? We know this 1335 newtons force makes 45 degrees with the x-axis. Hence, the horizontal component of 1335 is equal to 1335 into cos 45, which gives 943.98 newtons, and the vertical component of 1335 is equal to 943.98 newtons. Now, I will consider only the forces along x and y axis. This is the various forces that are acting along x and y axis. 819 newtons vertical, 445 newtons along x axis, that is given, and the component of the forces 398.03 and 198.97, and the other force components are 943.98 and 943.98. Let us calculate the net force acting along x-axis. So 398.03 and 943.98, these two forces are acting along positive x-axis. 445 newtons are acting along negative x-axis. That means net component force along x-axis is equal to 398.03 plus 943.98 minus 445, which gives the value of 897 newtons. Similarly, the net component of the force along y-axis, 890 newtons downwards, 943.98 downwards, but 198.97 is upwards. Hence, the net force along y-axis is equal to 198.97 minus 943.98 minus 890. That means I am considering x-axis. This side is positive and I am considering this side is positive. And then net along y-axis is minus 1635 newtons. That means downward direction. So here the net force along x-axis I got positive, so it is towards right side and the value is 897 newtons. Net force along y-axis is minus 1635, that means downwards, and that value is 1635 newtons. Now, according to the parallelogram law, the resultant force, so I can construct a parallelogram like this, and then the major diagonal R becomes the resultant. What is the magnitude of that resultant force? You know, square root under 897 square plus 1635 square. The parallelogram law of forces, I have prepared the concept in another video. Please watch that video. Now, the resultant force R is equal to 1865 newtons. And what about the angle made by the resultant force? Theta with x-axis is given by tan theta is equal to sigma Fy by sigma Fx. That is 1635 by 897. From that I can calculate theta is equal to, tan theta is equal to 1.822 or theta is equal to 61.25 degrees. Hence, this is the given problem. That problem I can convert into a single force with magnitude of 1865 newtons and makes an angle of 61.25. These two systems are absolutely same. All those four forces I just converted into a single force with an angle of 61.25 degrees. Problem number 2.20. Determine the magnitude and direction of the resultant of the four concurrent forces if each 445 newtons force is increases to 667.5 newtons. This is the given diagram. Now there are four forces. One force is 819 newtons acting downwards. Another force 1335 newtons force acting inclined. Another force acting towards left side, but this is not 445 newtons. This value is 667.5 newtons. And the last force is inclined force. This is also not 445 newtons. This is increases to 667.5 newtons. To solve this problem, let us transfer all these forces onto XY axis. Let us draw our XY axis like this. This is my X axis and this is my Y axis. I am transferring all those four forces onto this XY plane. First 819 newtons force I transferred, which is acts vertically downwards. Now the next force is 667.5 newtons force acts towards left side along x-axis. The next one is 667.5 newtons force. It is an inclined force. And the last one is 1335 newtons force, that is also inclined force. Now in order to solve this problem, first we need to identify the angles made by all the four forces along x and y axis. Now that 819 newtons force acts vertically y axis and that 667.5 newtons acts along x axis, but it is in the towards left side. Coming to the other two forces, these two forces are inclined force and these angles with either x and y axis we don't know. So in the first step we need to identify angles made by these two forces. Let the angle made by that 667.5 newtons with the x-axis is alpha. So this is my alpha. Now I would like to find that value of alpha. For that, let us consider the graph that is given in the problem itself. This 667.5 newtons force is intersect the graph sheet here. And you can take the each one as one unit. Let us say this is 1 unit. Let us say this value is x, and so this is also equals to x, and this is x. So if you construct a right angle triangle here, I can calculate tan alpha, that is x by 2x, which is 26.56 degrees. That means this value is 26.56 degrees. Similarly, the 1335 newtons force makes an angle beta let with the x-axis, and that beta I can transfer like this. This is my beta. Now what is that beta? Just by extending the same concept, this 1335 newtons force intersect the graph here. So I can construct a right angle triangle like this. So this is 1 unit, let us say this is x and this is another one x. So by using that right angle triangle concept, I can write tan beta is equal to x by x, that is equal to 45 degrees. Or you can take this point as the intersecting point. So you can construct a right angle triangle here like this. Then this is x, this is x, this is x, and this already x, this is x, and this is x. And this angle is beta. So I can write my tan beta is equal to 3x by 3x, that is equal to 1, or beta is equal to 45 degrees. So like that you can calculate that beta value, and that beta value is 45 degrees. Once you know the angles made by these forces with x and y axis, I can resolve all these forces into rectangular components along x-axis and y-axis. The concept of resolution of force into rectangular components, I prepared a separate video, so please watch it in RK tutorials. Now let us discuss one by one. That 890 newtons force is acts along y-axis, so you need not to resolve that. And that 667.5 newtons force acting along x-axis, that also you need not to resolve. Now that 667.5 newtons makes an angle 26.56 degrees with the x-axis. So the horizontal component of that force direction will be like this. Vertical component of that force will be like this. And what is the magnitude of that force? The horizontal component of 667.5 newtons is equal to 667.5 into cos 26.5. What is the reason? This 667.5 newtons force makes an angle 26.56 degrees with the x-axis. Hence, that x component will be the cos component. That becomes 667.5 into cos 26.56, which gives 597.06 newtons. On the other hand, the vertical component of that 667.5 newtons is 667.5 into sin 26.56, which gives 298.46 newtons. Similarly, the 1335 newtons force makes an angle 45 degrees with the x-axis. So I can resolve this 1335 along x-axis and y-axis. The x component of the force will look like this, and y component of the force will be like this. And what about the magnitude? The magnitude of 1335 newtons force along x-axis, that is horizontal component of 1335, that is equal to 1335 into cos 45, which gives the value of 943.98, and the vertical component of 1335 is equal to 1335 into sin 45, which gives 943.98 newtons. Now let us consider all these forces along x and y axis only. That 819 newtons and 667.5 newtons. These two forces are given. 890 acts along y-axis and 667.5 newtons acting along x-axis. For inclined 667.5 newtons force components are 298.46 and 597.06, and 1335 newtons force components are 943.98 and 943.98. Now let us calculate the net force along x-axis. Now here you can see 597.06 and 943.98. These two forces are acting along positive direction of x-axis. I will consider my positive x-axis is towards right side. And 667.5 newtons is acting towards left side. Hence, net force along x-axis is equal to 597.06 plus 943.98 minus 667.5, that gives the value of 873.54 newtons. Similarly, net force along y-axis, I will consider the upside is my positive. Then 819 newtons acting downwards, 943.98 acting downwards, 298.46 acts upwards. Hence, net force along y-axis becomes 298.46 minus 943.98 minus 890, which gives the net force along y-axis becomes minus 1535.52 newtons. That means the net force is acting in the downward direction. Hence, the net force direction is towards right side because my net force is positive, and that value is 873.54. Net force along y-axis is downwards because my net force along y-axis is negative, and that value is 1535.52. By using the concept of the parallelogram law. I have prepared a video for parallelogram law. Please watch it in RK tutorials. The resultant of these two forces will be like this. And the magnitude of that resultant force R is equal to square root under 873.54 square plus 1535.52 square, which gives the resultant force 1766.6 newtons. And let the angle made by the resultant force with the x-axis is theta, and the tan theta is given by the formula sigma Fy by sigma Fx. That is, tan theta is equal to 1535.52 by 873.54, and tan theta is equal to 1.758, and theta is equal to 60.37 degrees. Problem number 2.21. Determine graphically the magnitude and direction of resultant of the four concurrent forces if each of the 445 newtons force is reversed in direction. Now, the reversed directions of the 445 newtons is already indicated in the diagram. The one force is 445 newtons is acting in this direction, 819 newtons is acting in the downward direction, 1335 is acting in this direction, and 445 newtons force is acting in this direction. Our interest is to find the resultant of these four forces in graphical technique. So to draw the graphical technique, first I will take some scale. That scale is 1 centimeter is equal to 200 newtons. For each 200 newtons, I will represent with 1 centimeter. And I will just draw all these forces like this. First, any order you can consider. First I can take 445, next I can take 890, next any order I can take. So I will follow this order. First I will take 819 newtons force. That length of this newtons is calculated as 890 by 200 centimeters. That length is equal to this much. So first I will draw that line by taking one point as the reference. Next force I will take this 445 newtons. The length of this 445 newtons here becomes 445 by 200. I will just draw this line from the head of the previous force. That means I will draw that line like this. From the head of the previous line, I will start drawing the line of 445 newtons. Next I will take this 445 newtons horizontal. The length becomes 445 by 200, and I will draw this line from the head of this force like this. Next I will take 1335 newtons force. The length of this 1335 newtons becomes 1335 divided by 200. That force I will draw from the head of the last drawn. So I have drawn all these four forces by the concept of the graphical technique. Now the line joining of the first point and the last, or I can say the tail of the first point and the head of the last point becomes the resultant force. Please concentrate. The resultant force is like this. That is my resultant force. And what is the magnitude of that resultant force? For that I need to measure this length. This length is, after measuring, I will get that length as 11.31 centimeters. That I can convert into force by using the same scale. Hence, the resultant force R is equal to 11.31 into 200, which gives R is equal to 2262 newtons. And what about the direction? Just by draw a horizontal line and measure that angle. So this angle is the angle made by the resultant force with the x-axis, and that by measuring this by using protractor, I will get theta is equal to 63 degrees. Hence the final answers are R is equal to 2262 newtons and theta is equal to 63 degrees.